So again here, I got a little excited as I was finishing the last one, that carbon with the tetrahedral shape. Okay, the hydrogens around the carbon. What I forgot was the bond angle. So it's greater than 90 degrees, all right? And the bond angle is 109.5 degrees. 109.5 is the bond angle. Got a little excited and forgot to mention that. So tetrahedral shape, bond angle 109.5. Going to the next shape. The next shape is a pyramidal shape, or pyramidal. All right, obviously it looks like a pyramid. If we take a look at an example, nitrogen with 3 hydrogens. Okay, so nitrogen, 1, 2, 3, 4, 5. Hydrogen, 1 with 1 available, 1 available, 1 available. Notice we have the 3 available on nitrogen, and 1 available each on hydrogen. So we're going to have 1, 2, 3 bonds. Again, 3 different bonds, 3 different hydrogens. They all happen to be hydrogen, but they're still hydrogens. So when we clean this up, and with our unsharing pair, we look at it this way. Okay. Now this will not get trigonally planar, and the reason it won't get trigonal planar is because of the unshared pair. You have an unshared pair of electrons on nitrogen. Okay, so those are electrons, and since they're electrons, they also repel. So we can't get, since we have those, we can't get in this nice clean trigonal planar shape. It's just simply not going to happen because these repel as well. Now, they kind of repel a lot like the tetrahedral one. Notice what happens is, and again, I can almost put my nitrogen, here's the blue ball with the 3 yellows, I can almost put my unsharing pair on top. Well, what this does is it forces these other 3 to repel. If it was completely planar, this would be flat if there wasn't unshared. But because we have that unsharing pair on nitrogen, it forces some repulsion powers as well. So what happens is these electrons repel. What it does is something very similar to the tetrahedral, where here I'm holding the 1 hydrogen and nitrogen right here. We're going to have nitrogen. Notice that's why I keep my unsharing pair. We have 1 hydrogen in the same plane. This one's coming out at you. So there's my coming out at you dash, the triangular looking dash. And then this one is coming out behind you. So again, there you are. 3D, 3 dimensions, and here's the geometry with it. But the 3 dimensions, we got 1 in the same plane, 1 coming out, 1 going behind. This would be how you draw a pyramidally shaped molecule. Now what's the bond angle? The bond angle is 107 degrees. 107 degrees. It's not quite the same repulsive forces as the shared pair, and so therefore it's a little different than the 109.5 for the tetrahedral. So there's your pyramidal shaped molecule. The 5th and last shape is a bent molecule. Bent molecules, obviously, as the name implies, is bent. All right? Water is a perfect example of that. So if I have my hydrogen, and I have 2 of them, and I have my oxygen, 1, 2, 3, 4, 5, 6. All right? Notice that I have 1 available, and then of course 2 available here. All right? So my hydrogen and oxygens can combine looking like this. Now, oxygen, we might think would want to get like this with water. Via CPR, they want to get as far apart as possible. But they will not get linear because these unsharing pairs on oxygen are going to repel the shared pairs with the hydrogen. So, because we have these unsharing pairs on oxygen, it will bend. So that's what oxygen with two hydrogens is. A water molecule is a bent molecule. That's the geometrical shape. It has the two hydrogens. I have an example we put together here. Notice the red ball would be oxygen, two hydrogens, and it is bent shaped. Okay? The bond angle for a bent molecule is 105. Again, it's a little bit different. We've got two unshared pairs kind of pushing it down, creating that 105 degree bond angle. So those are all the shapes. In the next slides, I'll have some review and kind of take a look at some other things I like to remember when we think of shapes. But those are the 5 shapes. Obviously, there's exceptions to some rules and whatnot. But for our purposes, I think that's kind of where we want to be in this introductory chemistry class. All right.